All right, guys, last example. I just wanted to show you this one because sometimes there are some special cases where we actually don't just get one answer. So I went back to nice easy equations that are in slope-intercept form. This one on top has a slope of -1/2 and a y-intercept of 2. So that would be starting at y equals, or the y-axis on 2. Right there. And a slope of -1/2 means go down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2 if I reverse that slope. So that's a line that looks like this. Now, the bottom equation has a slope of -1/2 and a y-intercept of 4. So that is starting right here and also going down 1, right 2, down 1, right 2, or up 1, left 2. Now, when I connect this one, you can see what happens here is, unlike the other three examples, these lines don't intersect. On the other three examples, the answer was where they intersected. And if these don't intersect, how can I have an answer? Well, that's exactly the problem here. So since they never intersect, you would just go no solution. There's not going to be a single point that would give me a true statement for both equations. There's also a weird type of answer where, let me just back up. So let's say my bottom equation was y equals -1/2 x plus 2. Now, if that was the case, they're the exact same equation. Now, it might not look that obvious right at the start, but if you go and maybe your equations are in standard form and then you have to put them in slope-intercept form, and then you realize they're the same exact equation. If this was the case here, I have the exact same equation. I'd be graphing a line directly on top of the other line. So if your graphs are directly on top of each other, that means they're intersecting everywhere. If that's the case, then it's actually infinite solutions. Because these lines go on forever in both directions. So any point that lays on these lines is a solution to both equations. So there's three types of answers. In the first three examples, you had one solution each. In this video, I showed you that you could either have infinite solutions like right here, or you could have no solutions if your lines never cross.